đã dành thời gian để mình tham dự cái buổi event ngày hôm nay của bên em, bên Global Cloud với bên Yugabyte và AWS. Thì hôm nay thì mình sẽ có chủ đề là Jumpstart với YugabyteDB. Thì hôm nay thì sẽ có spa speaker sẽ nói về buổi event ngày hôm nay. Thứ nhất là có anh Đô đến từ IAA, và thứ hai là sẽ có Ron đến từ Yugabyte, và sẽ có Vườn đến từ Global Cloud. Thì đầu tiên chắc là em xin được rất lại cho anh Đô. Anh sẽ nói chuyện, anh sẽ nói về cái chủ đề sẽ thêm kinh từ IAA.
Thank you for, I hope you give an introduction about me. So I work in AI and data science, and I work for AI Vietnam in the capacity of leading the data science and AI team. So I do a lot of technical stuff, but today I don't want to talk too much technical because that is what I do every day. So just check. Can you hear me? So I do a lot of technical stuff, and I do a lot of technical presentations to different clients. So I just want to move out of the technical space today and talk to you about something which is very interesting, something which we are trying out in the offices, and something which we have tried out in other organizations and seen that it's working really well. And it's an interesting area to be in, because there's a big hype about AI, right? At the moment, OpenAI is there; they're putting out stuff every week, right? Very interesting things, like exceptional things. So the question for companies is, how do you actually integrate this AI into your organization? It's a big problem, right? If you're a startup, maybe the problem might be a little bit small. But if you're a big company, a big organization like the organization I work for, there are many different business units. So how do you get all these people into the bandwagon of AI? How do you actually make sure that we can use AI to get a competitive advantage? Right? How do you do that? So it's not as easy as plugging in some OpenAI plugin or using ChatGPT. It's not easy as that, right? So I just want to talk to you about a process which we are trying out, which you can also try out and see how you can actually do AI at an organizational level. So that's the presentation about. So the method is called design sprints, and I will take you through that method in a very, how do I say, structured way. I hope. And what I want out of this presentation is for you to try this out. Experiment because it's open. You can do whatever you want to do with it. I will just give you the building blocks so you can think about it and try it at your organization. So this is the agenda, right? So we want to understand why we need design. Then there's a difference between design thinking and design sprint, and then comes to the nice part, the framework which you can apply. Right? So design. So what is design? Right? And why do we actually care about it? So most of you are technical people, and I know when you work with a lot of design aspects also, right? So you have phones, you have shirts, like trousers, chairs, everything. All these things have been designed by somebody, right? These are not naturally born things. Right? So when you go to nature, you see trees, animals, those are all naturally born things. But what we use mostly, the chairs, the hubs, the computers, all the screens, those are designed by something, right? So, for me, in my personal opinion, design is something which is not natural, we create it, right? So, what is design, right? So, design is just using creativity to solve problems or to innovate. This is my opinion, right? It can be different for different people, but I think design is using creativity to solve problems or to innovate. So there are three parts to this. First, there is a mindset, like how designers think. Right? That's the first thing. The second thing is there's a skill set. Right? There's some tools, techniques which they use to actually do the design. The third thing is there's a process, like how they do. Right? So you have three things. You have a mindset, you have a skill set, and you have a process. Right? So we are looking into this in terms of all these three. Right? Now, why do you really want to learn about this? Like, what's the point? So, when you look at how you do AI in most of the organizations, for a lot of people, it's still a problem of where to start. How do you want to start? Like, what is the starting point? Do I want to do small thing, or can I just jump in and do a really big thing? So, how do you do it? Then the second problem is, how do you make sure that AI is democratized? That means everybody in the organization can come and do AI. It's not only for the data scientists to do AI. Right? So data scientists are like very specialized skills, and you can't find a lot of people also. But we want everybody in the organization to come and actually do AI. So how do you do that? Right? The third thing is, when you do AI, there are a lot of things which you need to think about, especially about ethics and governance. Right? So when you do AI, you take somebody's picture, right? And then what happens to them? You take somebody's voice, then what happens to them? Then you can create synthetic voices, images, faces. So there are so many problems in this. Right? So how do you actually manage the ethical side of that? How do you think about it? The fourth point is, how do you make sure that whatever projects you do actually bring in the return on investment? Because AI is not cheap, right? AI at large scale is very expensive, right? So if you do that, how do you bring all these things, the return on investment, back to the company? So how can design help to do this? So that's the question, and that is why we actually study this. So you know what is design, right? There's three things. There's a mindset, there's a skill set, and there's a process. And there's a thing called design thinking. So what is this design thinking, right? So design thinking is mainly about using the design mindset to solve problems. Simply, right? You can go to any technical definitions of this, but like no need. But simply, you can think of using the designer's mindset to solve complicated problems, right? So how do they do that? They do that using two ways. So this is more of a traditional way of looking at it, and then you can take this and little bit twist it, right? And change it a little bit to accommodate different scenarios. So this is called the double diamond. Like, I think most of the people are familiar with this, or you can call it the 4Ds. Right? So there are 4Ds. So there's the discover, the define, develop, and deliver parts. Right? So what this is, if you look at it, the most important thing is you go and try to find the right problem to solve. So this is the first part. Right? So you discover and you define, and you try to find what is the right problem to solve. If you know the right problem to solve, solving it is not a big problem. Right? As Einstein quoted, if he has 1 hour to solve a problem, he will take 55 minutes just to understand what is the problem, right? Then the solution is very easy, right? So the first part is more towards the problem side. How do you actually understand problem? So you can do it in two ways. One is what we call the divergent thinking, getting a lot of options, and then fine-tuning these options to come to a definition of the problem. That is called the convergent. So first, the first two Ds are for the problem space. Then once you know the problem, once the problem is very well defined, right, or problems is defined, or parts of the problems, then you can go to the solution space. So you again go back into the same divergent convergent thinking. You find a lot of solutions, and then you fine tune those solutions to find one or two things which you can actually solve, right? So it's convergent, divergent, convergent, right? So this is the first framework which you can do. So we take this framework a little bit and we twist it, and this is what you will, if you Google search design thinking, this is what you will see as the process, right? So there's 5-stage process, right? The first thing is you empathize, then you define, then you ideate, then you prototype, then you test, and then you launch, right? And the interesting thing is, this is not a linear process like this. This is an iterative process. So it's a non-linear process. There are feedbacks coming from the different sections, right? And these feedbacks will make it really powerful. So this is what we call design thinking. It's just using the design thinking principles in a way to solve complicated problems, right? But this takes maybe sometimes weeks or months or maybe years, right? So in an organization, you can't do that, right? If you go to your boss and tell, okay, I can solve your problem, but it will take me 6 months to solve the problem. Maybe he said, okay, fine, forget about it, you leave the company, I will find somebody else who can solve the problem very fast, right? So you can't do it in organizations. In organizations, you need to do things fast also, right? You can't just take your own time and think about it, right? Oh, this is a nice design, I will do this like this. You can't do it, right? So you have to do things fast. You have to iterate, right? And then you move forward. So this process sometimes it has problems because it takes time. So the solution is how do you actually compact and compress this? The compact and compress version of this is called the design sprint, right? It's a compact and compress version. That's why there's a word called sprint. You know, sprinting, right? Sprinters they run very fast. Right? So this is a compact and version. So this has 5 days, right? So when you say days, I put a quote there also. This is not a technical day per se. This is a unit of time, right? This can be 1 hour, 2 hours, 3 hours, 4 hours, whatever. This is just a unit of time. Day means a unit of time, right? So what we do is we take that process and we break it into 5 phases, right? So the first phase is we need to understand it, right? Then we solve the problem using that double diamond thing, right? You think deeply about the problem and really understand what is happening. Then you find out the alternatives, right? Then most interesting part is you build a realistic prototype which you can actually test and you can show it to customers and see what is their reaction. And then you test this with the customers and you get feedback and you iterate the whole process, right? So this process goes on a loop, right? Until you find a solution which you think is meeting most of your customers' needs and make a profit, right? So this is the process and these are just time units, right? So usually when we do, we can do it in 2 days also. Like half days. It depends on you. So these are the building blocks. So there's 5 building blocks, right? So just remember the 5 building blocks. How you arrange the building blocks is up to you. You can arrange it the way you want. Right? Now what we do is, now we are talking about AI, right? The interesting stuff. So we take that concept we learned earlier, the sprint, the design sprint, and then we break it down into how we can use it to find an AI solution, right? So same thing, right? Same thing as the previous one, but now there are small differences, nuances, right? So the first thing is we first of all we need to understand whatever we do, is there a potential in this, right? Is there some scope in this? If there's no scope, we don't do it, right? So we first find the potential, right? Second thing is once we find the potential, we will start doing small concept, right? To check. First we want to understand whether conceptually this will work, right? Before actually going and building something. So we will do AI concept design, right? Small one. I'll talk how you do it later. Then we do the assessment, right? So first of once we have the concept, we need to understand if this concept can actually be done, right? Technologically, and whether the data is supporting it, right? If there's no data, very sorry, concept might be brilliant, but can't do it right now, right? Then we do prototyping, right? So this prototyping can be rapid prototyping or standard prototyping. Usually what we do is we just build it in a Figma, right? So prototyping. And then we take that prototype solution and put it in front of the customer and ask her, what do you think about this? Right? Does it solve your problem, right? What are the pain points? What are the gain points? Right? So this is usually the process for the AI design sprint, right? So how do you actually do it in a company? Right? How it actually happens in the company is like this, right? So as I mentioned earlier, the most important thing is understanding the problem to solve. Right? Once you know what problem you're going to solve, then you can solve it. Right? The concept here is don't fall in love with the solution. Right? You try to figure out the problem, the solution will come later. Right? Then you develop the concept. right? So there are two ways to develop concept. The concept can be either some process in the organization, right, or products or services, right? So you talk to the business people, you go and do a collaboration event, you facilitate the people. Like let's say all of you are business people, so I will go and talk to you. What is the process? Right? How do you do this? Right? So then once I know the process, I will try to develop the AI concept for that process. How do we do it? Is through the collaborative process, right? Then most interesting thing is once you have a concept, you have to do the governance and the responsible AI. RAI is the responsible AI. Whether the AI is fair, unbiased, all those things, right? So you need to do an evaluation on the fairness and the governance part. Then you do the technology and data check. Okay, I have a concept. I know it's fair. I know it's ethical. I know it's not making anybody any harm to anybody. Right now, is there data to do this? Like, can I do it right now, or can I do it in another 3 months time, or 6 months time? Where can I do? Does the technology support it? Right? Do I have the technology, or do I need to recreate the technology from scratch? Right? Do I have the proper people to do that? Right? I do that check. Then we go into the prototyping stage. Okay, if all things are okay, or check. Then I go to prototyping and I prototype. Right? So as I mentioned earlier, prototyping is just for me to show it to the customer and ask, okay, does this solve the problem? Right? Then I test it. Okay? So this whole process we will iterate until we find a reasonable solution. Right? Then in the company, the problem is, okay, usually you might have a data science team to do it, or AI team, or you will take some third party vendor, right, to do it. So you need to make a decision whether you want to build it or whether you want to buy it. Right? So how do you make the decision is once you test it, you will do a financial evaluation of the solution, right? Whether this solution actually brings me ROI and whether we have the capacity to actually do it at the moment, right? So depending on those two factors, I will decide whether I will buy it or build it. Okay. So let's say I imagine in my company there's no skill set or there's no technology or it's not financially viable for us to do it internally. So I will go for the buy option. Right? So I will get it done by third party. So if I go for the buy option, what I will do is I will call for different vendors to come. And because I have built the concept and I have the prototypes and I know that the customers are liking it, I will just pass those ideas to the vendors and say, hey, I have this idea, it is being tested internally, I know it works, can you build it? And we do a hackathon with these people for maybe 2 weeks or 3 weeks and try to find the best solution. Right? Once we find the best solution, we will select that vendor and move forward with them. Right? So we go to the execution phase, and once the execution phase or the evaluation phase has done, then we go into the execution. So that is the buy route. Right? If you want to build it, right, because you have already done it, right? The prototypes are there, you know whether you have the people to do it. So you just go and do the build after the event, and you just go and scale. So this is the different types of building blocks. So how we usually do it is, I will show you how it's done practically. It's done like this. So what we do is, when we actually ideate, we use something called AI cards. These are called AI cards, right? So everybody plays cards, right? So what we do is, all these AI cards, they have some AI use case, right? And the colors indicate whether the use case is a simple use case or a complicated use case, right? So once we understand the concept, let's say once we understand the process, we use these cards to actually collaborate with the business and come up with the idea of what type of AI we can use in this process. So it's all very simple things, right? So for example, There's one card that says AI finds relevant information. Right? So very simple, very business-oriented words, no technical words here. Right? There's no technical words. Just some simple introduction to AI, what AI does, and some examples behind the card. Right? So we do that. And once we do it, it's easy for the business to really place a card in the process and say, hey, okay, I just want something which is visual. I just want something to do with the voice. I just want something to take text and translate it to voice, or take voice and translate it back into text. Right? So it's very easy to convince the business, or very easy to get the idea out of the business by using some simple technique like this. So we use that technique and we build this whole concept development in a Miro board or Figma board, or maybe in a whiteboard, or maybe just doing it with a piece of paper also. We can do it. So we just build it and then we do the evaluation. For the ethics as well as the technology, we have another separate card like this, card deck, right? So we can just use the AI ethics cards or the technology cards to actually take the business through the flow, so that the business gets involved in each and every stage. So we are not doing things just as technology experts, we are doing things in collaboration with the business. We don't remove the business from the picture. Right? In most of the organizations, the problem is the technology guys will do technology independently, the business guys will do the business independently. There is no collaboration. Right? They don't come together and talk. The reason is technology guys talk all technical things. Right? If you ask something, they say, okay, I need this database, I will do this algorithm. Right? The business people don't understand it. And they actually really don't care about it. Right? They don't care about what technology we use or what algorithms we use. At the end of the day, what is important to them is, can that technology or algorithm solve their problem? If the problem is solved, they are okay with the technology. But with AI and machine learning, all these things, the issue is, even if the technology solves the problem, is it ethical? Can we use it? Is it responsible? Are there any biasness or any other things related to it? So we need to understand that also. Maybe it's technologically feasible, but ethically unfeasible. There are a lot of solutions like that. For example, face recognition. Right? Technologically possible, very easy to do now with all the technology. But ethical and governance problems are there. Right? Second one is voice. Technologically possible, very easy to do. Right? But there's a lot of ethical and governance problems with using voice, right? Especially with deepfake, right? So you need to understand that, and the business needs to also understand. The problem is, if you go and tell business, okay, there's something called deepfake or something, business doesn't understand how it works. But if you give them a card and show them how this works actually, then they might be convinced and they might understand your problem, right? So that is why we use certain things like this to actually make it much more fun and collaborative. So that the whole process is not an independent version of technology, but a collaborative effort between both technology and business, and even the governance. Right? So we do that, and we get involved finance people also at different stages to get the evaluation done. Right? Is it actually giving me the ROI? So usually if we do this thing, normally in a project, if the whole process, end-to-end project takes maybe let's say $1 million to do it. This part, if you do it properly, the first part until the testing part, it just takes maybe 3% of the total cost. Because you are not doing any big concepts, right? You are just doing the small things. So this part is just takes about 3%, right? So you have a budget, you spend about 3 to 5% of the budget to find the perfect solution or the solution which works, and then you can decide, okay, how am I going to use my budget and the rest of the 95%, right? So it's financially and economically also very feasible for the company. The second reason this is very interesting for companies is, once you do this concept development and testing and prototyping, even if you don't have the resources or the people or the money right now, you can have have a list of a portfolio of projects which you can actually work on. Right? You can actually have a portfolio of projects for future development, and you know the potential, right? So whenever you can get money or whenever you can get resources, you can actually focus your resources into this portfolio, and you can prioritize the portfolio, and then you can work on it to make it a reality, right? So the third part is because the business is getting involved at each and every stage of this, right? Each and every stage the business is getting involved. There is always going to be business backing for the project, right? You don't have to go and convince the business again, say, oh, I have a brilliant idea, I can do this, right? Because the business is the one who actually comes up with the idea, right, with your help. So you don't need to actually go and convince them again and again, okay, this is a brilliant idea, we have to do it, right? We have the technology, all these things, you don't have to do that, right? The fourth important part is because you have already done the governance and ethics and the responsible AI part earlier, right? You need to technologically do it, but you have an idea of whether it's going to be feasible. The process of actually governing this becomes much easier, right? Or else governing an AI project is quite difficult and quite challenging, right? So it becomes much easier down the line, right? Because you have already done the basic stuff before you fully commit or before you actually do the advanced versions. So those are the reasons why actually companies just this type of thing. Right? So with this, it comes to the end of my presentation. I can just if you have any questions, you can ask, or else I will hand it over to the next.
Trong trường hợp một cái câu hỏi rất là hỏi là Đô anh chị là cái trường đàn mà Đô đã chia sẻ cho mọi người. Không biết là anh chị nào có câu hỏi không anh?
Do you think that your model now is the number one in the world?
Which model?
Design thinking?
It depends on the application. That's what I told. It sounds. If you don't have the resources, if your organization is not matured enough to do these type of things, then you can't. Simple as that. If you don't believe in it, because there's two things, other things. One thing is you need to have the people who can actually do this facilitation thing. The second thing is you need some leadership or executive sponsors who believe in this, right? So you can't just start and go and combine business together and do it. And the third thing is you need to have an organization culture where you can actually start doing innovating these type of things and prototyping and all this type of innovative stuff, right? If you don't have these things, you can actually do it. But what I'm saying is, this is one way where we can actually come and enter the market. You can go and show it to your CTO or the CEO or the CFO or somebody and say, hey, there is a process like that, there's a method like this which will bring both technology and business together to find a solution. So if you like it, yes, let's start and do it with a small project. I always say, like, do it with, even when we start, we do with small projects. We don't tackle big projects because we need to show some benefits of that, right? We need to show at least we can bring in business and technology together so that they will work. So to answer your question, maybe it is best for certain things when the company is at a certain maturity level or the culture is there. If not, first you need to work with that culture and then start with it.
Okay, 20 years until now,
Yeah.
Nearly service company are manufacturing. Nearly when we want to sell something, they have a ISO 2000. Look like this as a standard guide. I hope that AI with design thinking like that will be replaced when during the time we build the ISO, we base on the process.
Yes, correct.
Can we apply that way to the new one?
So to answer your question about AI ISO standards, there are standards, but certain standards are coming up.
Yeah.
Right? Because not all the standards are there. So especially for the governance part, there are some standards. There are some standards which will come maybe in the middle of the year or at the end of the year. So some standardization is available at the moment. the process, as I told you, if you want to take the process, you just take the building blocks and take it to your organization and standardize it based on your organizational needs. You don't need to wait for some like ISO things to come to make it a standard. You can make it a standard because it's just the building blocks, right? You can arrange the building blocks the way you want and make it your own process and do it in your own company. Like nobody's stopping you from doing it. What I want to say is, like, I work in Agile, I work in design thinking, and I work in AI. I work in all these three areas. What I say is, even with Agile, the biggest problem is they just take the concept very conceptual. They don't think practical. Right? Just because you want to do something like this, and just because most of the documentation is like this, it doesn't mean that you have to do it like that. You have the creativity and you have the thinking. Like that's why I told you, like there are three things, right? One thing is the mindset, like how you look at it. The second one is the skill set, and the third one is the process. So if you have the right mindset, you can build the skill set and you can change the process. So it's all up to you.
Okay. And the third one is in application, we will learn many look like practical thinking or some other one.
Yeah, correct.
Yes. Can we apply?
Yes.
That's not it.
Yes, of course. So that comes up as part of the skill set.
Yes.
Like there's different skill set, right? So there's a skill set to understand customers. You need to do some consumer research, right? There's user research. How do you do that, right? Then how do you make the facilitation process very good? Because not everybody can facilitate, right? You need to learn about it. And then you can use any sort of other tool which is appropriate for this situation in that context.
Dạ không biết là anh chị nào mình còn có hỏi nào cho anh Đô đúng không? Nên có thể anh chị có thể giơ tay để đưa bức cho anh chị, có thể hỏi anh Đô về cái chủ đề anh Đô mà chia sẻ cho anh xin đây được. Dạ vâng, thì nếu mà không có câu hỏi nào thì chắc là thank you for the offer silent and we'll some hand the gift for you.
Thank you.
Thank you.
Vâng, vậy hello, vâng, thì em xin tới chủ đề tiếp theo, đó là chủ đề từ bên Yugabyte, từ bên Bronson.
Before officially click start, maybe just a show of hands. How many of you are developers? 1, 2, 3, 4, 5. 5 developers. How many of you are enterprise architects? No. Okay. How many of you are from business side? Not non-technical related. 1.
Business analyst.
Okay. What about the rest?
They are lecturer.
Lecturer.
Yes. They are AI professor from some university or.
Okay, I think we can get started. So, my name is Ron. I'm from Yugabyte, currently the pre-sales for Yugabyte, and today I will briefly talk about building a highly available and scalable data layer across geographic locations on AWS. So, just another question before I get started. How many of you are familiar with database or ever heard about database? Oh, good. All right. So just a little bit about myself. My name is Ron. Before joining Yugabyte, I was in other companies like Visa, where I was doing relational databases. I was also in Pivotal, where I was doing data warehouses, if you know Greencloud. Then in-memory data crates. And also, I worked in HP Admiral for building data platform and AI platforms for customers. Then now I'm at a Yugabyte, which is a distributed SQL database in the world. What to do of
Xin chào mọi người, em là Vượng, em đến từ công ty Radio Cloud. Hôm nay thì em cùng với Ron sẽ đi lên cho mọi người presentation overview về Jumpstart.
So, as for today's agenda, so we will first briefly walk through what is YugabyteDB maybe you guys don't know what is YugabyteDB. Then some of the typical use cases for YugabyteDB, why it's so different from other databases like Oracle. I definitely have heard of Oracle, MySQL, or Postgres. Right? Then I will do a quick demo. By the way, we are 100% open source. So if you are familiar with open source, you can set up in your own laptop to try out and play around with it. Right? Then lastly, our partner will do a quick demo on how to actually spin up a global cluster on AWS across different geographic locations. By the way, have you heard of Gartner Magic Quadrant? So we actually just made it to the Gartner Magic Quadrant last year, December, so a few months back, right? Among all the top database players around the world. And we are also in the G2 grade for the regional databases. Maybe this is a bit technical. I hope this will be used for the tech people, but for the non-tech people, just bear with me for like 2-3 slides. Right? So generally, for distributing the data, there were multiple ways actually in the market or in the industry how people are distributing the data in their databases. So this is how does Oracle distribute the data. So for Oracle, the standalone Oracle there's no way you can distribute the data, but Oracle has this another offering called Oracle Rack, where all the database nodes will share the same storage layer. Right? So you have multiple instances for the compute, then you share the same storage layer. You can distribute data as long as your storage can stretch across like 10 nodes, 20 nodes. Right? Then you can distribute the data. And the other ones like AutoDB or Azure Hyperscale, what they do is, this is more like a traditional way of distributed data. You have one primary, then you have multiple secondaries, and all your reads and writes go into the single node. All the writes on node are read only. Okay. Then for distributed SQL database, Yugabyte belongs to this category, the one in the middle. Each node has its own storage, each node has its own compute, and each node's compute can actually reach out to all the other storage. So it is actually so-called a multi-master or multi-active system. So the traditional databases are active-passive, but this is the active-active-active architecture or approach. Therefore, how does people or how does database replicate data? There are multiple ways as well. First is on the database layer, you just replicate the storage, like a SAN storage. You replicate the storage blocks from one node to the other node. Or the other way is you rely on the logs, right? There's a lot of red or hat log, which we call var. Right? When you insert the data, there will be some log generated. You just ship the log to the other side, let the other side to replay this log. Right? Then in this way you can replicate the data. Some of the examples like Oracle, Data Guard, Postgres. Then for the distributed database, like Yugabyte, what we did is that we actually rely on this consensus algorithm. I'm not sure whether you've heard of it. It's called Raft. Have you ever heard of it? No? No? Okay. So it's a distributed consensus algorithm. Basically, it will make sure that the data is replicated to multiple places synchronously, and it will only come into a consensus when majority of the copy are committed. For example, I write one record. Then this record will be asynchronously replicated to the other two, but it will only tell the client the record is committed only when majority of the copies. So if I have in total 3 copies, majority means 2. Only 2 of the copies are committed, then I will tell the client, okay, the record is there. So this is the overall architecture for YugabyteDB. Then generally for database layer, it's only these two, the query layer as well as the storage layer. Then on top of that is more of a management layer on top of it. Right? So for the query layer, we have two APIs. If you are a developer, of course you are familiar with MySQL, you are familiar with Postgres. So what we are doing here is without inventing another database language, we adopt what developers they are already familiar with. So we use Postgres as a database API. So what we did actually under the hood is that we took the open source Postgres query layer code, the C++ code, we took it over. Then we rebuilt the storage layer from scratch. That's why we are fully Postgres compatible, and we built another API for Cassandra API. So for those NoSQL database or for non-relational workload, you can use a Cassandra API. So Postgres for SQL, Cassandra for NoSQL. And generally for database, the query layer doesn't actually persist any data. It is actually a stateless layer. The layer that actually store the data is on the storage layer. Right? So as the name suggests, distributed database. Why it is distributed? Because its storage layer is distributed. Right? So it does data replication, load balancing, transactions, optimization. So far, any questions? All good? So this is the database itself. Let's look at the underlying infrastructures. So for underlying infrastructure, actually we are infra agnostic. We support AWS, GCP, all the cloud vendors, even Kubernetes as well as on-premises data centers. But the difference is that for the public cloud services like AWS, we have a native integration. So we will have a demo later, so you can see that you don't even need to manually go into the AWS console to provision EC2 instance, install the binaries. You just need to, within a few clicks, with your credentials, we will help you to provision the cluster with your AWS provision. And you can run it on, let's say if it is on AWS, you can run it on EC2 or VM based, or you can run it on Kubernetes EKS, Kubernetes based. Yeah, like I said, the reason why we use Postgres as a database API because we want people can still use what they are already familiar with. For example, people may use pgadmin to connect to the database, pgviewer or DB visualizer, right? And also different kind of frameworks. Developers knows this the best, right? And they use Java, Spring, Go, blah blah blah. When it connects to database, they will just use the Postgres driver, right? So if you are telling if you tell a developer that to adopt a new database, you need to change all these things, they may say no, I don't want to do that. But you say that okay, you don't need to change anything, but utilizing the power of Postgres compatibility, they will give it a try. Because they don't need to change anything, but leverage on the capability or architecture, the benefits that distributed SQL will bring. So this is the architecture. On the right hand side is actually the architecture for YugabyteDB. The left hand side is actually the architecture for a single node of database like a Postgres. Query layer, you have storage layer. Then, as I mentioned, we actually reuse the query layer from Postgres. Then we rebuild the storage from reuse the Postgres query layer, then rebuild the storage layer. Then we actually distribute the data across all the nodes in the database. Right? Then each node And for the client, you can connect to all the nodes in the database. You can read and write from all the nodes at the same time. That is not impossible for traditional database. For traditional database, you can read and write from one node and only read from other nodes because there will be consistency issue or data conflicts. But this is not an issue within distributed SQL. You can read and write from all the nodes while maintaining the data consistency. So later on, we will do two demos. I will tell you which are the demos. So these are the number of offerings consumption model we have. The one on the left hand side, this is the, as I mentioned, we are 100% open source. So you can find the source code, even our database source code over here. Then you can download the binaries and try out on your own. So later I will be doing a demo on the open source version. A quick one so you know how to set it up in even in your own laptop or whatsoever. Then the two on the right are the enterprise version. The one on the rightmost is the fully managed version, similar like the RDS. So you just click, then you get a database endpoint. All you need to care about is, okay, I need a database URL to connect to. Then this one is a self-managed, so it gives you more flexibility where you can run your database across multiple infrastructures. So our partner will do a demo on this to see how you can actually run a single Yugabyte cluster across multiple geographic locations on the platform. Okay. So when we are deployed on the cloud, there are multiple different models we can do. For example, we can do single region, multiple zone. Let's just take AWS 8 as an example. We can deploy into AWS Singapore. AWS Singapore is a region. Then we can deploy in Singapore's different availability zones. So we can spin up a single cluster across EC1, EC2, EC3. In case you lose one EC completely, its whole availability zone is gone. Your data is still available. There's no downtime. Okay. Similarly, we can run a single cloud multi-region deployment, meaning AWS Singapore, AWS Japan, AWS Sydney, Australia. You can run a single cluster span across multiple regions, geographic regions. The last one is multi-cloud, multi-region. So what is so different about distributed database compared to others? So there are a few points. Scalability. So generally, if you know about the traditional databases, normally they depends on, because of the architecture of the database itself, those databases can scale only vertically, meaning you will have a bigger and bigger machine. Instead of 2 vCPU, you will have 8, 16, 48, etc. You can't scale horizontally. But the main advantage of distributed SQL, since the data is distributed, you can actually scale horizontally, meaning that you just add another node, add another node, add another node. From single cluster, you can go up to 6, 9, 12, even 100 plus nodes. And resiliency part, I have briefly talked about it. Once you can have one failure, like using the 3-node cluster, you have one node completely gone. The data or the database itself is still available. You can still read and write from the database. Elasticity, you can always do on-demand scale out. For example, till the Lunar New Year, maybe a lot of people going online to buy stuff, right? The workload definitely will grow like 5 times, 10 times. Now, how do you cope with such situations? Actually, with distributed SQL, what you can do is that maybe 2 days before the Lunar New Year, you just scale your cluster, double or triple your infrastructure so on the day itself, during the Lunar New Year period, your infrastructure or your application is performing well. Then after the Lunar New Year, when the workload drops, right, then you just scale in. You remove scale from the like a 12 node cluster to a 3 node cluster, right, to save the cost. So that's what I talk about elasticity. Automation. So with the later the demo that we will be doing will show you how we automate all this stuff. That even deploying, scaling is all automated. You don't need to think about how do I log into the machine to do all this stuff. Yeah. Then I will jump on to some of the use cases like people normally use distributed database. Before I jump in, any other questions for what I've talked about? Any questions so far? Anyone? All good? Okay. Have you heard about the data residency? Anyone? Data residency. Okay, basically for different countries, they may have these regulations to ask you to put the data only within the country itself. Like in Europe has a GDPR requirement. Singapore has PDPA. Really for Thailand, Indonesia, each one of them have similar kind of data residency law. Basically, it states that for the PII data or for the personal identifier information, they need to keep this information within the country. You cannot let the information leave out of the country. So basically, simply put, you need to put those data in the server, which in the country itself. You cannot let those data leave out of the country, right? So these requirements actually leave a problem here. Let's see a typical example. Right? If you today you have an application, you're running a business, you have an application, you have a user interface, you will have your application itself, then you have a database, right? Today you are happily running. Then tomorrow, you may have do some modernization on your applications to make it microservices, have more resiliency, which is common nowadays. Right? Let's say tomorrow, you want to open up another branch or to expand your business out of the country to another geographic location. Normally, what will people do? They will just replicate everything, right? Set up a complete infrastructure in another region. Head to the tail, right? But did you find anything that is not convenient over here? Each one has their own set of system. Now, how do you make sure that the system has you can have a holistic view of all your data? How do you do that? So in Yugabyte, we have something called geo-resident or row-level geo-partitioning. It is actually meaning that, okay, for each of the location or region, I will put a database node over there. However, it is still a single cluster. Then this is the database table. Okay, this is the table itself. Inside the table, there's a column called the geo, meaning the location. It will define where do you want to store this piece of data. Let's say when I insert the record in geo equals to US, this record will be stored in the US database. When the geo equals to UK, this record will be stored in the UK database. If this geo equals to India, this record will only be stored in the India database node. So physically, the data is stored within the country itself. But if you want to have a global view, you can just do a select star because it's a single table. Right? That's how we tackle these kind of problems. This is just a detailed illustration. Like you have Europe, India, then you have 3 clusters. I mean, it's a single cluster but spanned across 3 different regions. The original data is actually stored in each server. so that when you retrieve the data, like when you only want to see the US data, then you can only see the US data, then retrieve from the database from the US countries. So what we can do is that for the PI data, basically the sensitive data which require to be seen in the local, you can actually use this feature to geo-partition it. Right? Then there are other data that is not sensitive. Then you can actually distribute it across all the geographic locations. This is actually one of our customer. They are a healthcare platform. So they are based in Europe. Basically, in Europe, they has a GDPR requirement, right? The data cannot leave the Europe. So basically, what they did is that they actually pin the data in the Europe itself for the sensitive information. Okay? So the data itself didn't leave the Europe, but if you want to query it from anywhere else in the globe, you can still query the data. So the first use case about data residency. Then the second one is digital native apps. What do I mean by that? So we do have a customer who is actually doing the cross-border payments. Okay. So initially they are using Postgres, like any other platforms. They use Postgres and it's an active and passive architecture. And when they analyze that, what they discover is that whenever they need to do an upgrade, there will be downtime, like minimum, like 1 to 2 minutes. It can up to 5 minutes downtime. And if you are using, for example, they are using GCP, right? So GCP will push you to do the database upgrade. Otherwise, there will be vulnerabilities, right, or patches. So they will force you to upgrade. So whenever you upgrade, there will be downtime. Okay. So they actually come to us because they don't want the downtime issue to happen again, as well as they want to actually globally distributed database where they can access the data from anywhere else in the world. So this is actually one of their architecture. So they have a primary cluster actually in Singapore. Then they have the replica clusters in Hong Kong, in US, in Europe. So all the rest of the world, they can still read the data, as well as maintaining a high availability. And this is another customer, digital native. So they are born in cloud, they build a solution on cloud. So they do build a solution for they use machine learning to prevent fraud. So it's an anti-fraud solution they built for the bank. So it's a fintech company. So this is a high-level architecture diagram we have. So here is the data source. Data source will be the ingestion pipeline. It can be real-time ingestion, it can be stretch ingestion into your online store. So actually, their online store is now powered by YugabyteDB. Then the online store, it will push the data to the offline store. They use S3 bucket as the offline store to store all the code data. Then their data scientists will actually do the build the model, to process the data, to train the model over here using the data in the S3 bucket. Then once they have a very accurate model which can detect the fraud, then the API will be called whenever they want to. There's data coming in. They will do the real-time detection of the fraud. So we have talked about the first one is the data residency. Second is digital native or digital native applications. Then the last one will be the database modernization. Right? So a lot of big enterprises, they have those legacy applications or database. How do they modernize it? So Terminals is, if you are in, how many of you are in banking?
Yes.
In banking. So you know Terminals?
Yes. What VA means, we know what VA means.
Okay. So Terminals is a very famous core banking software provider. So a lot of the banks, for top 50 banks around the world, 41 of them are using Terminals for their core banking transactions. So Terminals was originally using Oracle, but since now they are also modernizing their stack for their both for their application and databases, so they choose to move to Postgres first, because normally when people try to move out from Oracle, they will choose Postgres first because of the similarity. But the Postgres is not scalable enough. That's why they come to us for the. This is the number, like the benchmark number we have done with Terminals. So this is their own benchmark workload. It's called high order benchmark. It's from Terminals themselves. So for this benchmark, there will be 100 million users in the benchmark with 200 million banking accounts. We're able to achieve 100K business transaction per second. And from database point of view, we're able to achieve 350K reads per second and 80K writes per second, with the infrastructure running on the AWS across 3 different availability zones. This is another example. Like you heard of Oracle, of course. On the other side, you also heard of DB2, which is running on mainframe from IBM. So this is another customer who wants to move out of DB2, move out of mainframe. This is what they do. They do have on the application side, they do have modernized their apps, right? But now it's how do they actually migrate out of DB2 on mainframe? Frankly, this is very difficult if you want to, because DB2 has a lot of proprietary functions, and also for certain softwares on the mainframe, it needs these. It has certain requirements on the hardware as well. It's not easily decoupled. So what we did is that, I'm not sure whether you guys heard of this term called CDC, change data capture. So what happens is that whatever you write on the DB2, the same data will be strained to the downstream system. In this case, will be Yugabyte. So it will make sure that the YugabyteDB has the same data as the DB2. Then the application, instead of connecting to DB2, then now you can connect into Yugabyte for your other services. So bit by bit, you can actually migrate out of the traditional or the legacy systems or infrastructure. Okay. Then now let's jump to the demo part. I will do a short demo. I'm not sure if you have laptop. If you have laptop, you can take them out and play together with me. So the tool I'm using now is called YugabyteD. So what is YugabyteD? So it's just a daemon service to start managing the Yugabyte cluster. Okay. So if you have laptop, just take out your laptop and key in the thing. So we have some easy demos or hands-on workshops that is available on GitHub as well as on GitHub. So I will do a quick demo. Are you guys still able to see the screen?
Yes.
Okay. So this is a link. Okay. So when you come here, there are different kinds of workshops. But the prerequisite is that you need to have a GitHub account, then you need to have a GitHub account. Okay. Once this is ready, so you can open up this GitHub. So we will just start a note. And there are certain instructions over here as well. So let me just pull out this again. Just now you were here, right? So we open the keyboard, but the menu or the working instructions is over here. Once you click this instruction, it will be here. So it will tell you exactly what are the commands you need to run to get started. So what I can do here is I will create a 3-node cluster to mimic like if you have 3 EC2 VMs, what we're gonna do. So I will first create a directory for the data where it's gonna be stored. I will create a directory first. Then I will start the first node. So here I'm using the daemon YugabyteDB. I was talking about it. Okay. The first node has started. Then I will start the second node to join the first node. Okay. Then I will start the third node to join the cluster. Okay. Now let's just check the cluster status. And the cool thing about this tool is that we are using the open source, right? It's free of charge. And also this tool has come with a UI, built-in UI. You can actually visualize what is your cluster status. So you can go to the pods. And here. So I'm having 3-node cluster, 3-node cluster with a region and so on. So if you are using the EC2 on AWS, then this region maybe become like a AP Southeast 1, and AC become AC1, AC2, AC3. So this becomes a 3-node cluster. So I just need 4 commands to spin up a cluster. As simple as that. Then here are the database configuration, mostly are default configurations. Then you can also monitor how many database you will have, and you can have the basic monitoring of your performance as well. You can see live queries, slow running queries, etc. So you may wonder, how do I connect to the cluster? So this is our client tool. It's like similar to the PSQL, Postgres PSQL. Then you are in the database, right? So you may want to see that how many nodes I have in the cluster. 3 nodes. And pod, cloud, region, zone, IP. Right? Then you can do your normal database operations like create things. If I want to create table, let's say AWS with ID equals to int, and description is just txt. Then I can insert down values, let's say 1, and test. Basically, it is the same as a Postgres. How you, if you are a developer, so you know this very well. How you read and write and do all the operations with Postgres, you can do the same with. Okay. I think that's what I want to demo. Then next, I will ask our partner to demo the Yugabyte Anywhere, there, which it will show how to spin up a single cluster on AWS across multiple regions, across multiple availability zones, etc.
Em quan trọng từ team Renovate thì để một cái buổi này nó interactive hơn á, thì em xin hỏi mọi người là không biết là không biết là mọi người có đã từng gặp một cái khó khăn khi mà launch một cái giải pháp kiểu như hybrid, tức là ở bên dưới mình cần cái database ở trong cái on-prem server và mình cũng muốn cái giải pháp đó có thể extend trên môi trường cloud, thì không biết là có ai mà có anh chị nào đã có gặp cái vấn đề tương tự như vậy chứ? Mọi người có thể thảo luận và trao đổi. Thì đối với việc là bọn em thực hiện consulting các cái giải pháp ở trên với các khách hàng ở trên Việt Nam, thì có một số cái customer enterprise customer họ muốn sử dụng hai cái giải pháp song song, đó là sử dụng ở dưới on-prem cũng như là sử dụng cái data ở trên AWS để có thể thực hiện các cái mục tiêu về analytics, có thể build ra các cái data product ở trên AWS, nhưng mà họ cũng đồng thời họ lo sợ những cái về cái tuân thủ luật, hoặc là họ cũng có những cái hệ thống mà không thể migrate hoàn toàn trên AWS, cho nên họ quyết định là vẫn có một số cái hệ thống là sử dụng on-prem. Cho nên là cái giải pháp ngày hôm nay mà Yugabyte đề xuất, đó là cái Yugabyte Everywhere, thì có thể là extend globally, có thể deploy trong cái môi trường on-prem lẫn môi trường public cloud. Vì khi mà mình deploy cái multi cloud, giải pháp multi cloud thì đây là cái UI, tức là khi mà mình sẽ thực hiện thì để cho cái phần này nhanh thì em sẽ show cho mọi người cái cách mà mình thực hiện. Đầu tiên thì mình sẽ thực hiện cái UI. Thì khi mà mình thực hiện cái cổng việc thì mình sẽ tạo một cái cổng việc mới. Thì ở trên cái infrastructure mình cần deploy, thì như ở đây là mình sẽ deploy ở trên môi trường AWS. Đó, thì mình sẽ hiện điền các cái thông tin và các cái thông tin thì mình có thể tên cho nó. Mình có hai cái cloud information mà mình có thể tùy chọn. Thứ nhất là mình có thể sử dụng asset key, và thứ hai là mình có thể sử dụng role trên AWS. Nếu mà asset key thì mình sẽ điền asset key vào đây. Rồi cái AMI thì default của nó là exclamation, và mình sẽ sử dụng cái region, có thể tùy chọn cái region cũng như là VPC. Thì cái này thì mình có thể copy từ bên motion này AWS file config, xong thì copy cái VPC ID security và visual. Rồi mình cung cấp thêm cái VPN, cái user vào. Sau khi vào fix xong cái configuration là sẽ xếp cái configuration đó. Thì ở đây thì để cho nhanh thì mình có thể mình có thể lưu bọn em đã có các cái trước đây. Về config backup thì mình sẽ tạo ra các cái backup ở trên này, các cái backup ở trên S3. Backup mình có thể tạo ra một cái S3 bất kỳ để chứa các cái dữ liệu backup, và mình sẽ có về security mình có thể cung cấp một cái các cái giải pháp về encryption như là EMS của AWS, thì đó là về security. Và khi mà mình đã thực hiện cái config xong thì mình sẽ deploy cái universe, tức là các cái database across multi-region. Ví dụ như đây là một cái cái cluster này nó sẽ có 3 cái node ở region US East và có 3 cái node with replica ở region sau East. Đơn giản under the hood của các cái node này là các cái con EC2 có thể và cái con EC2 cái con EC2 thì mình có thể hiện các cái bước create universe, và ví dụ như ở đây mình sẽ có là total node 3, replication factor là các cái odd number, tức là các cái số lẻ, tức là mình sẽ ví dụ như một cái data, một cái table mình có thể chia ra làm 3, replicate ra 3 hoặc 5. Mình có thể chọn instant file cũng như là immediate volume, và dựa vào cái config ở trên AWS thì mình có thể thực hiện được cái tạo được cái cluster này, cũng như là sau khi mà mình tạo được cái primary cluster có thể kích sang with replica, tức là mình có thể with replica tạo ra một cái con 3 cái node with khu vực khác. và các cái này thì mình sẽ thực hiện các cái connect, thực hiện các cái DDL, tức là define các cái table tương tự như các bạn làm from rồi thì vô cho thì chắc là đến đây thì em drop up cái show cho mọi người cái cách thức hoạt động trên AWS. Cái phần này của em thì đã kết thúc cái buổi ngày hôm nay. Thì ở đây sẽ có các cái đường về feedback survey, thì mong là các anh chị sẽ scan và đưa ra những cái feedback cũng như để cho YugabyteDB và team Renova có thể thực hiện tốt hơn vào lần sau.
Không biết anh chị của mình là khi nghe cái demo từ phía Yugabyte phía bên Yugabyte Cloud á, không biết anh chị mình có câu hỏi nào mình ra cách thức mình thực hành trên Yugabyte hay là trên AWS đó, không biết anh chị nào có câu hỏi là được tính hỏi thì bên có phía Yugabyte và bên Yugabyte Cloud nếu trả cho mình trả lời câu hỏi.
Ok, anh cũng hỏi tức là cái Yugabyte này nó hỗ trợ multi-master, vậy thì phải giải quyết cái vấn đề mà conflict khi mà nhiều cái write cùng một dữ liệu như thế nào. Ví dụ như cái demo bạn nãy ha, insert với ID text thôi, table rất đơn giản. Vậy thì sẽ select có hai cái master, rồi anh insert cái ID bằng 1 ở cái lần thứ nhất, đó là ID bằng 1 và text bằng ra đi ở một vị trí khác, insert là ID bằng 1 luôn nhưng mà với giá trị là v. Đó, tức là cùng một khi các value mà hai nó đang connect qua hai cái con master khác nhau, vậy thì nó giải quyết cái conflict sẽ như thế.
At the same time, so you can write on the master ID.
So this actually depends on the isolation level you set, because in database terminology there's a multi-version concurrency control and also the isolation level. Isolation level defines when there are multiple sessions or transactions happening at the same time. If you are reading and writing within the same transaction or modifying the same record, it defines like how you can actually modify that record. So if the isolation level is high, for example, is serializable, it will only process if you are modifying the same record, the ID equals to 1, then the other, if you are updating the value, one is updating to 2, the other updating to 3, right? So what happens is that it will serialize it. So it will first transaction coming first, then the second. Then, or there will be other cases like it will wait, or it will just wait until the first transaction completes, then the second one will come in. Or there will be like you can, for the second transaction, it will strip away through an error, saying that there's a conflict, transaction conflict. Then the second transaction will fail immediately. Then you need to retry again later. Yeah.
Yeah, but I think the master nodes need to synchronize with each other.
Yes.
So so when I execute transaction on clients, so it needs to wait for the master node to synchronize with each other before returning the result.
Actually, there's a global transaction manager inside it. Just that from the technical architecture I didn't show it. It is actually the transaction manager handles when there's a transaction. It handles everything. So it knows the metadata, whether there will be transaction conflict, all these things, it will know. So all the transaction conflicts need to go through that transaction manager. Transaction manager knows the isolation level, knows the version, knows which node needs to contact. So it's like coordinator.
Yeah. So where is the transaction manager? So I see only the master nodes. I can see the transaction manager.
Transaction. There were 2 layers on the T server side. I mean, there's the master server. Transaction manager is actually within the T server itself. It's part of the storage layer.
So for Yugabyte, in the CAP theorem, we are consistent first before availability. So we make sure that data will never get lost. Data is always consistent in the distributed architecture. So today, the major problems with most databases is they are eventually consistent, one master and one slave. For Yugabyte, because we are doing multi-master and at the same time ensuring we follow the CAP theorem, so financial transactions will always be consistent. This is the biggest problem for financial transactions when you're writing across AZs or writing across data centers. So there is a chance of data loss or data corruption when there's a network failure. So this is something that most of the financial institutions are trying to resolve. Because in the past, 3 seconds only means maybe 3 transactions. Now 3 seconds can mean 300 transactions when you have a network interruption. So that's why in the Yugabyte design, we always value consistency over availability. Because we are a clustered system, it solves the problem of availability as well. So in Yugabyte, it's guaranteed transaction consistent, 100%. So we can go a bit more detail next time if you wanted. You can contact us. We can run you through the mechanics of how we distribute the transactions.
Yeah, or maybe we can search for the documentation of Yugabyte.
Yes, correct. You can find it in there. So most of the applications people are building today value scale, because a lot of time for developers they only focus on getting it to work first, and then getting it to scale is a problem down the road. We are trying to solve the problem up front by giving you a distributed architecture, solving the scale problem on day one. You don't have to worry next time if I grow from a small application to a bigger size application, uptime scaling will no longer be a problem. And this is something that we are starting to face because every single digital interactions, you have a data growth issue, you have an uptime issue, you have a security issue because you need to patch. So we are solving all these problems using a distributed architecture.
Không biết là anh chị mình có câu hỏi nào cho phía cái được không?
Is there any when you or you say something like or multi-master?
Okay. So Aurora multi-master, it has certain limitations. Like you can go through the documentation, but mostly for the database features, it has certain limitations. Like for example, certain data type is not supported. This kind of constraints. If you want a full database features, I mean we are more compatible, Postgres, etc. And the other one is the charging model is a bit different. Like Aurora, it's I mean the storage really plays a big part. Like when your data scales and your cost actually it's not a linear scale. That's what I can say.
I think most importantly, a lot of people are looking at database as something that potentially you want to harmonize across different infrastructure. Whether it's Kubernetes, whether it's on-premise, whether it's on one cloud or the other. So generally, they want to simplify the operations. And the whole ideal part is I can take that single database and run it anywhere I want. Whether it's running on AWS within one region or one country or multiple countries, or I want to run it as a hybrid model because I want to take advantage of cloud elasticity. But because of, for example, GDPR, PDPA, I need to keep certain data within the country, and the cloud vendor don't happen to have something within the country. So this is something that we can use distributed database to manage. Whether you are talking about I'm trying to manage latency, so put the database closer to the apps, or I'm trying to manage between different infrastructure. So for our perspective, we are basically providing you with a database as a service layer where you can run it anywhere.
Anh chị một câu hỏi đúng không? Cái là một câu hỏi của cái giơ tay ha. Có hỏi là gì không?
And what's the price model?
So we have the cheapest model is open source. You download it, you use it for free.
The one I run free of charge.
Yeah, so the whole idea for this community is a lot of people wanted to build a future cloud native stack. So you can easily download and use it without any cost.
And you can see how easy it is. I run a cluster, right? Yeah. 4 commands I run. Then the 3 node cluster is
Yeah, because sometimes you may need to operate it within your different infrastructure. The second model is bring your own license model. You can run it, you can deploy it across any infrastructure with a single control plane. That means I can sit in my office, I can deploy on cloud, on-prem, on multi-cloud, on hybrid cloud to support the business. Because some business will need to run in different countries and they want to simplify the management of them. So that is bring your own license model. In that model, we only charge you production. All non-production are free. So the last model is a SaaS model, similar to what all the cloud vendors are doing. We run off AWS. You tell us what you want, we will just manage it for you. Yeah, but it's basically based on vCPU, nothing more. No IOPS costs, no nothing. So egress, we built in a certain amount of egress for you as well. Yeah. So basically, it's a fixed cost model where you don't have too much surprises.
Yeah, but then we reason we use the commercial license. So what is
Why would you use commercial model?
Yes.
So the automation.
The second demo is actually the enterprise.
Okay.
model.
So automation, but more importantly, a lot of people for databases, they want a few things. They want SLA to resolve things. They want certain security posture to be implemented. They want certain advice. So we are first and foremost a database company. Our bread and butter is database. So we will work with customers not just to manage the SLA, but we also have to give them advice. And we also work on optimization with them. So for example, the biggest e-commerce company in Indonesia is called Tokopedia. They use the open source version first. They use it actually for a year to replace their Postgres. Because Postgres, you have vacuum. You have a lot of administration problem. You have scalability issues because of the volume of transactions. So they work on the open source version. Then they realize that I don't want to do this alone because distributed architecture also is something that we want to work with the vendor to understand better how to design. And then they work with us and they went on to the enterprise edition. So today, 70% of their workload is being run off Yugabyte Enterprise Edition. They still have 30% running on open source Yugabyte. So literally they can do the co-creation model depending on the criticality of the workload. Because not necessarily every customer want to pay for a subscription. Certain workloads non-critical, I run open source. The one that are mission critical, I run Enterprise Edition. Is it okay? Yeah.
So I have seen from the second demo that Yugabyte is like as a code in this one it's easy to work.
Yes.
Yeah. So is it like you can manage because normally whenever my database on these tools I have to manually increase the file district and all that. We also so like I did on administrative tasks. So if I run if I use like YugabyteDB and all that, so I have to manage that like all like increase the file district manually by myself into the side. It's just something that you guys.
No. So basically, the whole idea is that you are providing your AWS credentials to the platform. So the platform use your credential to provision all the required resources. For example, EC2, the OS, the disk, download the things, configure things for you. So it's like the platform like handles the VM, handles the automation part for you, but the EC2 VM itself is actually owned by you. It is your own VM.
So I don't have to do any administrative
Yeah.
tasks.
Yes. So that's actually the difference between the open source and the enterprise. Enterprise does more automation for enterprise features for you, right? Because for enterprises, people don't like to log into to manually provision the VM and log in the server, SSH in, then install the configure. They don't like this kind of thing. They want everything to be automated, to have a certain standard processes. So,
Any other questions? Like for example, developers like to build things on Kubernetes, right? So with us, you basically have a Kubernetes ready database. You don't have to go and think about how do I run a database on Kubernetes. And Kubernetes inherently are distributed in nature. So same thing, we will scale like our applications now. So you can start small and scale. You can be elastic in nature without affecting uptime, which is one of the biggest problems when you talk about traditional database. I always need to size on peak. I always need to provision for peak, although the peak only happens maybe once a month. So now with this kind of technology, you can actually harmonize your spending. You start small and scale on.
Dạ vâng, các bạn anh chị mình không còn câu hỏi nào nữa thì rất là xin cảm ơn cuộc sẽ đến
actually, before you leave, you can scan the QR code, just a survey form. And also, if you book a demo with us with qualified, then you can get a $20 voucher. Okay.
Yeah.
Okay, thank you.
Xin mọi người sẽ nói tốt là mọi người cái survey giúp cho bên em bên local làm. Vì sau khi mà mình làm xong survey mọi người có thể ra ngoài có keyword bên ngoài